Okay, let's take a quick look at the answers for the do now. Right, remember at this point in time, you should really just be checking what you've got on your paper. For 15, I can do 1 times 15, place the 1, place the 15. I can also do 3 times 5, place the 3, place the 5. That is a composite number because there are more than 2 factors. I can do 1 times 24, place the 1, place the 24. I can do 2 times 12, place the 2, place the 12. I can do 3 times 8, place the 3, place the 8. I can do 4 times 6. There's the 4. There's the 6. There are more than 2 factors, so it is composite. 19, all I can do is 1 times 19. And the reason why that's all I can do is it's a prime number, right? There are exactly 2 factors. That number is prime. 32. Okay, I'm going to slow down a little bit on this one. So I'll do 1 times 32. There's 1. There's 32. Now, I'm going to try 2, and if need be, I might even grab a calculator and say, hey, calculator, what on earth is 32 divided by 2? 16. Okay, so 2 times 16. Next, I'm going to try 3. So, okay, I'll see 3 times, and if need be, get a calculator or use some scratch paper. 32 divided by 3. Uh-oh, that comes out with a decimal. Won't work. Let's try 4 then. And of course, 4 times 8 is 32. And so we finish that off. Right, so that is composite because there's more than 2 factors. But notice if I'm not certain, I try 1, then I try 2, then I try 3, then I try 4. Right, I go in order. For question 5, 1 times 1 is all you can do. There's only 1 factor. So this is the neither, right? It is not composite because it doesn't have more than 2 factors. It's not prime because it doesn't have 2 factors, right? That number is neither. 162. Now this is where my organized skill comes in, right? 1 times 162. Does 2 work? Well, I can consult a calculator and find out. It's 2 times 81. Place the 2, place the 81. Does 3 work? Well, moment of truth, you can grab a calculator. 162 divided by 3. Oh my goodness, it worked, 54. I'm going to try the next number. I'll try 4. 162 divided by 4. Oops, came out as a decimal. I'll try 5. 162 divided by 5. Oops, that's a decimal. How about 6? 162 divided by 6. Ooh, that's exactly 27. Okay, so there's a pair for us. We've got one more pair we have to find. Let's try to divide by 7. 162 divided by 7. Oop, nope, decimal. How about 8? 162 divided by 8. Nope, you get a decimal. How about 9? I'm starting to get a little bit paranoid here. 162 divided by 9. Holy cow, comes out to be exactly 18. Now, don't be surprised if later today or next week you're asked to do some of these and I don't have the blanks for you, so you don't know how many you're looking for. Obviously, this one was composite. Factor trees, let's get through these real quick. Oops, we've got a phantom already showing up there. Factorization of each number after making the factor tree. So for 70, let's try 7 times 10. I'm going to circle 7, that's the prime number. Underneath 10, I can do 2 times 5. Circle the 2, circle the 5, because those are prime numbers. The tree is done because every branch ends with a prime number. So I got to go in order. I see a 2, and then a 5, and then a 7. Remember, we can use those dots for multiplication. For 72, I can start with 8 times 9. 8, of course, is 4 times 2. Circle the prime number 2. 9 is 3 times 3. Circle the prime number 3. Underneath the 4, I can put 2 times 2. Circle those because those are prime numbers. Now, tree's done because every branch ends with a prime number. What's the smallest number that I circled? Well, smallest prime number is a 2. How many of them did I circle? I circled 3 of those 2's. Did I circle anything else? Yes, I circled a 3. So let's put a 3. How many did I circle? I circled 2 of them, so I got 3 to the second power. So 2 to the third power times 3 to the second power is the prime factorization for the number 72. 77, what can I do? Well, I think the only thing I can possibly think of is 711, right? 7 times 11 makes 77. 7's a prime number, I better circle it. 11's a prime number, better circle it. So the prime factorization is just 7 times 11. Okay, so our new material today, proportional relationships, right? For a lot of this unit, we were just kind of brushing up on some skills that we should have learned in the past. So some of you were in a review mode, some of you were actually learning. But now we're actually in the curriculum that is expected for unit number 3. So we'll be studying proportions. A ratio shows how many times one number contains another. And whenever you see the word ratio, think fraction, right? If you see the word ratio, think fraction. And then a proportion is an equation in which 2 ratios are set equal to each other. So if you see ratio, think fraction. If you see fraction equal fraction, think proportion, right? When we have a proportion, it's an equation where one fraction is set equal to another fraction. Or, in other words, when one ratio is set equal to another one. Okay, so if you flip over your do now, you got some blank spots. So let's start taking a look at them. All right, so for the first one, please copy this down. I've got blank over 8 equals 10 over 16. And our job here is to try to figure out what number needs to go above that 8. Now, this is one of the ones where you might be able to just eyeball it and say, oh, duh, obviously, right? If it's not quite so obvious, I'm thinking, I know on the bottom of those fractions, if I do 8 times 2, I get 16. And so I need to figure out what mystery number times 2 is 10. Now you might notice why we like to use dots for multiplication, because if I'm going to use x as a variable, right, as a mystery number, I don't want to have both a mystery number x and an x that looks like multiplication in the same equation. I'm like, ooh, this doesn't look too good. Well, obviously 5 times 2 is 10, right? So 5 is the number I need on top, right? 5 over 8 is the same as 10 over 16, because 5 times 2 makes 10, 8 times 2 makes 16. And again, this is one of the ones where I kind of say, like the eyeball method, you just kind of look at it and say, oh, gee. Same thing with number 11, right? A lot of you could just kind of take a look at this question and say, oh, I know the answer, right? But we got to compare the ratio 7 over 20 to the ratio blank over 60. Right? Again, when I think of the word ratio, think fraction, right? The ratio 7 over 20 is the fraction 7 over 20. And we call this a proportion because we got fraction equals fraction. Well, the denominator, I do 20 times 3, that gets me 60. Notice I'm using that dot for multiplication now. So in the numerator, well, 7 times 3 makes mystery number x. Well, 7 times 3 is 21. Okay, it's 21. Now, if you were a 7th grader, this is kind of what we would be doing, and this is probably, hopefully, what you did last year in 7th grade. But you're 8th graders this year. We're going to get more and more proportions that look like this. So please copy this one down. 12 over 15 equals 20 over blank. 12 times 1 is 12. That's not what we're doing. 12 times 2 is 24. That's not what I'm doing. What on earth am I going to do with that 20 and that 12? Right? This is not one of the ones where I can just eyeball it. And so we need to learn a method to solve proportions. That method is going to be known as cross multiply. Okay, so I'm going to cross multiply. So first I'm going to look with the part of the cross where I've got my missing numbers. I say, I got 12 times some mystery number. Now, in math for mystery number, we like to use x. I want to put that as 12x. Notice instead of 12 times x, I can put that little dot there. 12.x. And now the other part of the cross, 15 is across from 20, so I'm going to do 15 times 20. But again, I'm going to use that little dot for multiplication. So I got 12 times x equals 15 times 20. 15 times 20, you might be able to do in your head, might be able to do on paper, you might have to grab a calculator. So now I've got 12 times mystery number x equals 300. So if I want mystery number x, well, the opposite of multiplying is dividing. We practiced this skill quite a bit in September, right? Long division. It'd be acceptable if you have a handheld calculator if you wanted to do that method. So it looks like mystery number x has to be 25. And so now I can complete the proportion, right? 12 over 15 is equal to 20 over 25. But this is the method I'm going to need to use, cross multiplication. So these next 3 examples, that's the method I'm going to be showing, right? Again, at any point in time, if I just start going too fast, hit pause, hit stop, hit rewind. Number 13, please copy this down. Blank over 12 equals 10 over 8. All right, so when I do my cross product or my cross multiplication, the first thing I want to look at is the one that lines up with the blank. Okay, the blank is across from the 8. And for my mystery number, I'll use x, so 8 times x. Now, if you're wondering if your eyesight is going bad, and you're like, I don't see that dot between the 8 and the x. Well, since x is a variable, if we just put the 8 right next to the x, that means multiplication. That means 8 times x. Let's look at the other part of the cross. 12 times 10. Again, I'm going to use that dot for multiplication because I'm using x as a variable, so I don't want the x that looks like the multiplication symbol. 12 times 10. Should actually have this one memorized, right? Or just say, hey, if I multiply by 10, I just add a 0. Now, 120 divided by 8, this is not something you'd have memorized, so this is where you need to practice our favorite skill from September. Or if you have access to a handheld calculator, this would be a good time for a handheld calculator. Mystery number x is 15. I can complete the proportion. For question 14, please copy down 9 over 12 equals blank over 8. All right, so 9 over 12 equals blank over 8. Since I'm trying to have a fraction equal to another fraction, we call this a proportion. And we can solve a proportion using a cross product, or some people will call it cross multiplication. Again, I start by looking for my blank numbers. I say, okay, it'll be 12 times my blank. For my blank, I'll use x, so 12x. The other part of the cross is 9 times 8. So 12 times x equals 9 times 8. 9 times 8 you should have memorized from your multiplication table. Same thing with 72 divided by 12. That should also be memorized from your multiplication table. And we get 6. So there's an answer. Number 15. Blank over 8 equals 27 over 6. All right, so make sure you copy that down. Blank over 8 equals 27 over 6. Cross multiply. It looks like the blank is across from the 6. So I will do 6 times blank. Of course, I will use x for my blank, right? So 6 times mystery number x equals. Well, the other cross is 8 times 27. Now, for question 13, multiplying by 10, piece of cake, you just add a 0. Number 14, 9 times 8, piece of cake, you should have that memorized. Number 15, 8 times 27, oh boy, right? You're not going to have 8 times 27 memorized. Right, so I gotta go through here, 8 times 7 is 56, put down the 6, carry the 5. 8 times 2 is 16, plus 5 more is 21. So 8 times 27, 216. Right, I worked it out by hand. And if I do have access to a calculator, what I usually do is I'll usually work it out by hand and then check with the calculator. Or if I do it with the calculator first, I like to check by hand, make sure I didn't just accidentally push incorrect buttons. So if 6 times mystery number x is 216, to undo the multiplication, we gotta divide. So, right, here's that skill that we practiced again and again and again in September. Right, long division is a skill that's not going to go away. In fact, when you get up into algebra, not only will you use long division with numbers, you'll use long division with polynomials. So if you're like, "Whoa, what does that mean?" Well, hang around for some high school algebra, okay? So it looks like mystery number x is 36. Now, I wasn't going to have you copy down an entire word question, so it's pre-printed, right? So this question is printed on your paper, but notice the directions. The directions don't say solve this any way you want, right? You need to solve it using a proportion. Of course, you're looking at number 16, you're like, well, I don't see a proportion. The proportion is fraction equals fraction. I don't see any fractions. Well, we need to set one of them up. We need to set up a proportion. Right? I got two individuals here. I got Wendy, I got Fred. So I want to think of Wendy, and I want to think of Wendy as a ratio. Right? Fancy word for fraction, a ratio. Well, I know she purchased 4 pounds of coffee. I know she paid $53.08. Right? So there is Wendy represented by a ratio. Okay, now I want to think of Fred represented as a ratio. Right? Or as a fraction. Now, with Wendy, since I put the pounds in the numerator, for Fred, I need to put the pounds in the numerator. Right? On Wendy, if I had decided to put the money in the numerator, with Fred, I'd have to put the money in the numerator. You can choose what you want to do. If you want to put pounds over dollars, put pounds over dollars. You want to put dollars over pounds, put dollars over pound. But you have to be consistent, right? However you set up Wendy's ratio, you have to use the same format for Fred's ratio. And notice, since I don't know how much money Fred is going to pay, I'm using X. All right. Remember, when you see ratio equals ratio, you have a proportion. So if it says solve for proportion, I need ratio equal ratio. Now notice when I try and solve this, I'm just going to use the numbers, right? I don't put 4 pounds, I just put 4. Instead of $53.08, I just put 53.08. Instead of 5 pounds, I just put 5. Instead of X dollars, I just put X. But when I'm setting it up, I need to make sure I know that I'm consistent with my units, right? So if I use the numerator for pounds, make sure the numerator is pounds on both of them. If the dollar value is the denominator, make sure it's on both of them. Cross multiply, I gotta do 4 times X. And then I need to do 53.08 times 5. I'm like, uh-oh, this is a little bit tricky because I don't want to use the X symbol for multiplication because I'm using mystery number X. And I don't really want to use a dot for multiplication because that's going to get confusing because I have a decimal point, right? And even though the dot is higher up, it's like, well, so what can I do? Well, if I put each factor inside parentheses and put them next to each other, that's another way of showing multiplication. Right, so one of the factors, 53.08, is in a set of parentheses. The other factor, 5, is in parentheses. Remember, when we're multiplying, each number that we're multiplying, we call them a factor, right? Factor times factor equals product, right? The answer is a product. Okay, I probably don't have this one memorized, and you're probably not going to do this one in your head, so I can work it out with pencil and paper real quick. 265.40. So 4x equals 265.40. Of course, I want the value just x, so I don't want 4 times x, so opposite of multiplying is dividing, so I got to do some division. Again, I'm not going to be able to do this one in my head. All right, so I can go through my long division algorithm. And I'm coming up with, it doesn't look like it's going quite in order in the replay, but okay, there we are. It looks like 66.35. All right, so all right, X is 66.35. Now, before I do my victory celebration, this was a word question. Word questions should have word answers. All right, don't just tell me 66.35. The question is, how much did Fred pay? Fred paid $66.35. All right. You don't have to have a huge long sentence for your answer, but we got to have some words, right? Word questions need to have word answers. Fred paid $66.35. Okay. Have fun with the worksheet. You're going to be practicing solving some proportions. When you get done solving proportions, we've got some various work from throughout the unit. We want to keep those skills sharp on a daily basis, right? We want to make it so natural that by the time a test day rolls around for our summative assessment, you're so comfortable with the work. It's like, oh yeah, I know how to do this. I've been doing this for days and days and days. Monday, I better be back on Monday. Apologize. Apologize for not being there today.